Okay, so just picking up where we left off, the idea here once again is that if I have two objects that are colliding in elastic collision, then I need to know more information than just their initial conditions. I've got to know something that's happening after the collision because I've got too many variables to deal with. So in this collision, what I will say is that let's take the first box, let's have it bounce backwards, and we'll have that speed be 1 meter per second. And this was our 5 kilogram box. And then now finally I can solve something. Here's my 10 kilogram box. And now I can have this be an unknown. I'm going to call that V2F this time. And I'll call that unknown. So you see what I really need is I need 3 pieces of information here to solve this elastic collisions. At least how we're doing them now. When we start to talk about energy in a while, then we can solve them a little more easily. But I need this piece of information, I need this piece of information, and I need this piece of information in order to solve the problem. So let's go ahead and figure out what the solution to this problem is. What's V2F? Once again, same thing. I start out with, let's see here, the sum of all the initial momentum equals the sum of all the final momentum, right? Now initial momentum, we got to pay attention because there's a positive and a negative. So I get 5 kilograms times 4 meters per second plus 10 kilograms times minus 2 meters per second, right? Pay attention, that speed right there is a negative speed, right? And that's going to equal, now pay attention as well, I've got a negative speed here, 5 kilograms times negative 1 meter per second plus 10 kilograms times V2 final, right? Pay attention, that's negative as well. It makes a really, really big difference right there. So let's just go ahead and keep solving this. And I'm going to once again drop my units just to make things easier. So I get 20 plus negative 20. Oh, well, that's interesting. That's going to be 0. Equals negative 5 plus 10 V2 final. That gives me 0 starting out there equals negative 5 plus 10 V2 final. 5 equals 10 V2 final. So V2 final is 0.5 meters per second, right? And notice how this is a positive number, which means it's going in the right direction. Let's just go back and check out our drawing to see if that actually makes sense. Okay, great. It's in the positive direction over here. I needed this guy to be going in the positive direction. So that's good that I got a positive number out of it. Let's just look at one more thing as kind of a general case here so we can just get a general formula for what's going on, right? So let's see. Just draw some lines again and a general formula for what's going on. So this time I'm going to keep everything in variables. M1, V1 initial. I have to label that as V1 initial. Now I'm going to label this one M2, and I'm going to put V2 initial. I don't know whether V2 initial is going to be positive or negative, right? This could be a positive number or it could be a negative number. So it could actually be that V2 initial is going that way. I'm not sure, but it'll be given in a problem, right? We're just keeping them variables for now. And then the collision's going to happen. And then I've got, once again, M1, and I've got a V1 final, which it doesn't really matter which way I draw it, but let's keep it in that direction. V1 final, and I've got my M2, and I've got a V2 final as well, right? So there's a lot of variables there, a lot of things to deal with. You'll have to be given a number of them and then solve for the one that you don't know. There's a lot of variables. But keeping with our conservation of momentum, the sum of the initial momentum equals the sum of the final momentum. So let's just add them all up. A lot of variables to keep track of. M1 times V1 initial plus M2 times V2 initial equals M1 V1 final plus M2 V2 final. Now what we could say is this is sort of a general equation, and it looks really similar to what we did with inelastic collisions. And in fact, it's really the same equation. The only difference is we now might have a different speed for V1F, and V2F might be different. When we had inelastic collisions and they stuck together, then V1F and V2F were the same. Now when we have elastic collisions, when they bounce, these guys might be different. So just pay attention to that.